Here's a wild question for you. Can you actually trust your own hands? It's a pretty unsettling thought, right? I mean, we navigate our entire physical world relying on our sense of touch. We use it to comfort our loved ones, to test the bath water, to check if the stove is hot. But what if I told you that your physical senses are literally lying to you all the time? What if the very hands you trust to interact with the world are completely unreliable narrators?
Okay, let's actually test this out with a beautifully simple, maybe slightly cruel little experiment. It takes just 3 steps. Picture this. 3 containers in front of you. Container A has warm water. Container C has ice-cold water. You dip your right hand into the warm water and your left hand into the ice-cold water. And you just sit there. You wait for 1 full minute. You really let your hands get entirely used to those extremes. Then, for step 3, you take both hands out and plunge them simultaneously into container B, which is filled with perfectly ordinary room temperature tap water.
And bam! Here is our tragic flaw. When you plunge both hands into that single bowl of tap water, your brain gets 2 wildly conflicting reports. The exact same tap water is going to feel distinctly cold to your right hand and undeniably warm to your left hand. Your sense of touch is easily fooled. It is, quite literally, a liar. It just cannot tell us the exact objective truth about hotness or coldness. To truly understand our physical world, we have to bypass our biology entirely. We need a way better tool.
Enter our cold, unfeeling, but completely honest saviors, scientific instruments. So what are we actually looking for here? Well, temperature is a reliable measure of the exact degree of hotness or coldness of an object. It's a concrete number. It's not a feeling. It's not a random guess based on touching a mug of tea. It is an absolute objective reality that we can record, we can compare, and most importantly, we can trust unconditionally.
And that is exactly what temperature lets us do. It gives us a totally concrete way to map the wild, dangerous extremes between, say, a raging fire and absolute ice. By assigning an actual number to these states of matter, we strip away all that flawed human perception and replace it with universal truth. But you know, to have a universal truth, humanity first had to agree on a shared language.
Which brings us to the scales we use to map those extremes. It's fascinating, really, to see how different parts of the world and different fields of science agree on what hot and cold actually mean, using water as a baseline. We've got the Celsius scale, where water freezes at a clean, easy 0 degrees and boils at 100 degrees. Then we have the Fahrenheit scale, which you're probably used to if you're in the US, where freezing is 32 degrees and boiling is 212 degrees. And then for sure, we have the Kelvin scale, the absolute gold standard for scientists, where water freezes at 273.15 Kelvin and boils at 373.15 Kelvin. Basically, 3 different languages telling the exact same truth.
So how do we actually capture that truth? Enter the thermometer. Honestly, it's an instrument built specifically for this exact job, and its mechanism is just beautifully simple. A liquid, usually mercury or colored alcohol, is sealed inside this incredibly thin glass tube. When the environment around it heats up, that liquid physically expands, and because it's trapped in a super narrow space, it has literally nowhere to go but up. When it cools, it contracts and falls. The level just lines up with the printed number on the glass, giving us the unvarnished truth. No guessing required whatsoever.
But here's the thing. While that basic principle of an expanding liquid is absolute genius, we humans need very specific types of thermometers depending on the job, right? Like, the tool you use to check a child for a fever is fundamentally different from the tool a chemist uses to measure a boiling acid. Different extremes require entirely different constraints. Let's start right at home with the human body. 37 degrees Celsius, or, 98.6 degrees Fahrenheit, is the normal temperature of a healthy person. Because our human biology operates in such a fragile, incredibly narrow window, the clinical thermometer doesn't need to measure the extreme temperatures of fire or ice. It only features a tiny range, specifically from just 35 degrees Celsius to 42 degrees Celsius. And honestly, that is all it needs to tell us if we are healthy or if we are dangerously ill.
And this super narrow range allows for a frankly brilliant little physical design feature called the kink. It's just this tiny, narrow bend right above the bulb of liquid. So why does it matter? Well, think about it. If you take a thermometer out of someone's warm mouth and pull it into a cold room, the liquid should instantly contract and fall, which would totally ruin your reading. The kink physically stops the mercury from sliding back down. The reading stays firmly put until you purposefully reset it with a really hard flick of the wrist.
Which leads us to a rather grim warning about using the wrong tool for the job. 100 degrees Celsius, the boiling point of water at sea level.
Listen, if you ever decide to take a clinical thermometer, which remember, maxes out at 42 degrees, and dip it into a pot of boiling water just to see what happens, you are going to experience a very sudden, very dangerous tragedy. The liquid inside will expand so rapidly and so far beyond its intended scale that it will violently shatter the glass tube. So yeah, don't do that.
Right, so to avoid shattered glass and a lot of disappointment, we turn to the laboratory thermometer. Built for the harsh realities of chemistry and physics, it has a way wider typical range, spanning from -10 degrees all the way up to 110 degrees Celsius. It comfortably handles boiling water, but crucially here, it has absolutely no kink. The liquid moves freely. This means if you take it out of a hot substance, the temperature immediately drops. You actually have to keep your eye exactly level with the liquid column while it is still submerged to avoid what scientists call a parallax error.
Okay, let's switch gears and dive into another specialized measurement, the weather. Now, you might think measuring the air temperature on a sunny day just means, I don't know, holding a thermometer up to the sky, right? Actually, scratch that. The sun is basically the enemy of an accurate air temperature reading. If direct sunlight hits the glass of the thermometer, it heats the instrument itself, giving you a falsely high reading of the glass, not the actual air. To get the true temperature, these everyday air and max-min thermometers have to hide. They're placed inside a shaded, specially ventilated box called a Stevenson screen.
And hey, speaking of measuring the weather, this brings us to one of the absolute heroes of our explainer today, Anna Mani. Widely known as the Weather Woman of India, she was this brilliant physicist and meteorologist living from 1918 to 2001. She realized super early on just how absolutely vital these truth-telling instruments were for her country's development. She designed and built a huge range of weather measurement instruments, including precise thermometers, right there in India. By doing this, she massively reduced her nation's dependence on imported technology. She even went on to research wind and solar energy, helping push the entire country toward a future of renewable power. She literally dedicated her life to building the machines that tell us the unvarnished truth about our environment.
So, here we are at the end of our explainer, and I want to leave you with a somewhat unsettling thought. We've basically proven today that your own hands cannot reliably tell the difference between hot and cold without the help of expanding liquids trapped in glass tubes or specialized digital sensors. We rely entirely on machines to tell us the objective reality of the temperature around us, which kind of forces us to ask, with maybe a slight sense of existential dread, what else are your senses lying to you about right now?